For the last speech of this first session, we will have a trio who is a brilliant example of cooperation inside MNHN itself. So Cécile Callou is director of a support and research unit named BBEES, BBEES in French, meaning biodiversity, ecology, environment, and society databases, but it's quite a wow. And Chloé Besombes is head of acquisition and treatment service at MNHN Libraries. Francis Clément is deputy director for digital innovation and IT. And together they built bridges between it's difficult to say, heterogeneous data silos toward an MNHN data hub.
Thank you. So to begin this presentation, it seems to be necessary to explain what is the situation at the museum in the large field of data today. This one, I'm sorry. Because all data correspond to all the facets of the museum, libraries, of course, but also naturalist collections, fundamental and applied research, naturalist expertise, and so on. This slide tried to show the organization, or not organization, of data and databases in the museum today. As you can see, I know you know, this approach is based on an extremely complex and unstructured digital ecosystem. While libraries and scientific publications are quite naturally structured and connected to national or international systems, the other systems have their own production and dissemination practices, sometimes with recent organizations. For example, this is the case for the collection databases linked to the National RecordNet infrastructure and the International Distributed System of Scientific Collections, DISCO, which makes European naturalist collections available. This is also the case for expertise databases linked to the Nature and Landscape Information System and Global Biodiversity Information Facility, GBIF. Don't forget data from citizen and collaborative sciences from VG program. And to finish, research data. Since the recent publication of the French National Open Science Plan and the link with the French data infrastructure. If dissemination outside the institution is more or less organized for each data silos separately, within the museum, the situation is more complex. This silo exists without any links between them. They are completely separately. Even if some data are more and less shared, such as taxonomical information or geographical locations. Another recurring data in datasets and data repositories is people names. People who collect, observes, analyze, describes, records, illustrates, writes, and publishes. However, as you know, various shapes of people names exist. And if persistent identifiers are used in libraries and scientific publication databases, text or even abbreviations are usually used in collections databases. It's the reason why DataPOC project was created. DataPOC for proof of concept, but also for people of collections. The project was carried out in 2 steps. Both using semantic web technologies, both benefited from funding opportunity collects per se. A first step on one sample of 500 names with the help of a Logilab company. And a second step with taking account of all names present in databases. So it's 300,000 names with the sample. And the work is directed by with Mnemotics company. In this step, we include also non-publishers. It's a new system. It's not publisher, but also non-publishers. Naturalist observers, anonymous collectors, and also citizen collaborators. The main goals are standardization of people's names, even when the representations are different, as in this case, for Jean-Baptiste Pierre-Antoine de Monet Chevalier de Lamarck, Lamarck, and you have different form for the name. And also solve the problem of homonyms and be able to indicate whether they are related to the same person. Specify also family relationship, in particular those of naturalist dynasties such as Antoine, Bernard, Joseph Jussieu, Frédéric, Georges Cuvier, Étienne or Isidore Geoffroy Saint-Hilaire. And this family tradition still exists today inside the museum. And for that, with the help, with taking into account the age at the time of the event, birth and death dates, where they can be found, and it's a problem, and the correlation with date of the event. For example, to avoid finding a specimen collected before the collector was born. It's current in the database. And identify regular co-authors, shared collecting sites or discipline. For example, François Perron and Charles Alexandre Le Sueur are collected together in Australia. So it's a help to find what's happened. And now we show you what is databook.
So I will present first the deliverables included in the project. And there were, first of all, a structured dataset taking the shape of a knowledge graph. The second deliverable were a website and an API allowing to explore this structured and linked data. We built the website also to curate the data graph, to spot wrong data and export visualizations in order to correct wrong data in the data sources. And the third deliverable were reports about the algorithm used to conciliate all the different forms of people's names and how it could be improved in order to make it more efficient in other versions of the application. For the moment, the algorithm to conciliate data is simple. It uses shape of the name and dates, but the idea is to improve it in future versions of the application. Here is a list of the databases involved in the project. As one of the main goals of this project was to link museums' data, we chose to include several museums' databases. And first of all, we include all the catalogs for library material, print and manuscripts, the catalog of the scientific publication service, and the catalogs for naturalistic materials. We also include institutional open access repository to have a large literature in this project. We decided also to include external national and international databases or authority files in order to strengthen and enrich the data. So you have the list and Wikidata too. So how does the system built by Mnemotics, the company, work? So you have the schema. The data are extracted from the sources, and then they are transformed as RDF triplets and put into a triple store. Then the data are indexed and analyzed as to align them, detect the errors, and calculate metrics, for example, the distance between two similar data. Once they have been processed, they are made available via the API or the website. It's simple. So, after describing this system, I propose you a quick demo based on short screens in order to show you the main functions of the application. I'm sorry, I know short screens are not the best, but yesterday the application was buggy. Yeah. So
It's classic.
I considered it was a bit risky to do it in live. So it's not very alive, but you have the link on the PowerPoint, and if you want to, you can play with it after. So this is a short screen for the home page, which shows the list of all the people names currently found in the databases selected in the project. Some information appears in front of each name. You have the name here and information. And here you have the source of the data. It's really interesting, and you can sort the result on this column by source. It's an interesting function. And at the top of the list, I don't know if you see well, you have the search bar here. You can search by name in the list. So this is an overview of a people's page. So when you click on one name of the list, you have this page that appears. It presents diverse sections. First, some information about the person, different shapes of the name, persistent identifiers attached to this name, and some information like status of the person or biographic information. Concerning identifiers, the application generates a PID that it's meant to become a museum ID used in databases. And then you have a list of other PIDs, IDs, identifiers you can find attached to the person in other databases or authority files, national and international authority files. After that, you can find diverse sections presented on the same way. The list of Then, first of all, you have the alignments proposed with other forms of this name, which are calculated from the analysis algorithm. And here you have a bug message, but you can see, you will have the opportunity to see the alignments in another slide, sorry. So, alignments are usually here. And after that, you have other section that presents the list of collaborators of the person, and then the list of his or her scientific activities, bibliography, scientific supervision, determination, collect, etc. Each section gathers all the activities of the same type this person did, and which are described in the databases. So you have the different sections, collaborators, publishing, contributor, and so on. If you click on one of these sections, a table will appear, a table like this, and presenting for each output a clickable link that redirects the user directly to the source of the data. In front of each link, you have some information about the output, the shape of the name associated in the source, some notes, and the source where the name was found. You can export each table, this table, in CSV or JSON format in order to help curate data in the source databases. All the functions I have already described are open to every user. Some advanced functions are open only to authenticated users. As an authenticated and authorized user, you can validate or invalidate the alignment. So here you can see the alignments proposed by the system. So you have the name. You cannot see here because it's a show screen, but it's on the top. And then you have all the proposition for Cécile of alignments proposed by the system. And here, as you are connected and authorized, you can validate or invalidate just pushing button the alignment. It allows the user to curate the knowledge graph, because once you invalidate or validate the alignments, it is recorded by the application. Another advanced function is you can also modify person pages. You can delete them, and you can add a person to the list. Modifying the person page includes enrich the data related to the person, add information, add identifiers, add relationship between the persons, like family relationship. And you can also manage data updates from this page if you are authorized. So from the diverse databases involved, and you can launch the updates from this page. To conclude this quick demo, we are very satisfied with the result of the project. It needs to be improved, of course, but we hope it could turn into a real authority file for the museum, which can include also non-publishing people, and that was one of the main goals of this project. And also, we would like to improve the application to help us to correct wrong data or poor quality data in our databases. And now I will let Francis.
I would like to introduce you a new project that will be launched at the end of the May, that is called datahub. 1 year and a half, I started my job in the museum, and one of the things I heard was integrative taxonomy. Do you know what it is? No? Okay. It's a way to integrate information in order to position, to better understand, to position a specimen in the tree of life. It's very important for taxonomists in the museum and beyond in researcher laboratories. I will just give you a short overview, because I have 5 minutes, a short overview of this project. Once I heard talking about the integrated taxonomy, I asked people how can we help these researchers to work, and I heard about the datahub. So, yeah. So we talk about the datahub, what the datahub can. How can datahub would be a stack, a technological stack for the datahub. I'm sorry. And then everyone in my team say we can do this. Can use this stack, technological stack, the other stack. And I say, let's start the datahub project. That would be a proof of concept for us. And I can testify it works. Today it works. So we decided to use the architecture of the datahub for the datahub. But why? Why? Because datahub is focused. No, datahub is focused on people. Okay, datahub is focused on people. Datahub is focused on specimen, so we can use absolutely this. Absolutely the same technology, the same treatments, but thanks to datahub, we can now focus on treatments and not in technology, because this architecture works for us. And Thank you. At the first time, we asked ourselves the question, how can we help people who work in integrated taxonomy? And now we can humbly think that at the end of 2K24, we'll be able to provide a new tool for them to connect a specimen with picture 2D and 2 and 3D, BHL, hair, and etc. Different data sources to help them to go faster in their research. Of course, the project will kick off. The kick off the project is in the next May, but with Databug, we think that at the end of 2K24 we can finish this project.